This is another one of my Flat Earther encounter videos. This encounter is with Bev, Try Thinking, and I've subtitled this Dishonest Argument Tactics. I was on the Emma UK Discord server for about a month perhaps, and I engaged in several ultimately fruitless encounters with Bev, but I'd like to show you the last one I was involved in. So he asked me if I had any contribution to the debate about the shape of the Earth. And I said that the surface we're on has an impact on how we observe the things above us. So observations of the lights in the sky, which is what Bev likes to call the celestial bodies. He calls them lights in the sky. Observations of lights in the sky can tell me something about the shape of the surface I observe them from. Bev says the surface we're on does not impact how we observe the things above us. Yes, it does. Observations from a flat surface are different from observations from a spherical surface. Then Professor Bevel, as he calls himself on the server, misrepresents my argument. He says the geometry of an object is not affected by the lights. He has inverted my argument. I did not say that the geometry of an object is affected by the lights. I said the surface, or the geometry of the object, has an impact on how we observe the things above us, or the lights. In other words, the geometry of an object affects how we observe the lights. I did not say that the geometry of an object is affected by the lights. My statement is P affects Q. The statement he purported was Q affects P. So he responded to my argument by disagreeing with an argument I didn't make. He inverted my argument. He then asked me to restate my positions as if P then Q logical statements. So I said if the surface of the Earth is spherical, then the relationship between your latitude and the angle between Polaris and the horizon should be nearly linear. If the surface of the Earth is flat, then the relationship between your latitude and the angle between Polaris and the horizon should not be linear. Then I ask, do we observe a linear relationship between an observer's latitude and the angle between Polaris and the horizon? And Bev asks for an explanation of the term linear. So I provide him the mathematical form y equals mx plus b. That is a linear equation, or a linear expression. It's not good enough for him. I present him with a graph. This graph shows your latitude north of the equator in the x-axis, and the y-axis is the angle between Polaris and the horizon. This is a straight line, thus there is a linear relationship between your latitude north of the equator and the angle between Polaris and the horizon. This is still not good enough for Bev. He then asks if I'm allowing for perspective as a function of distance. And I say yes, perspective as a function of distance would result in a non-linear relationship. And he asks why, and I explain what is completely readily apparent in any observation you make, which is that the angle that an object moves in your field of vision decreases as its distance from you increases. Let me unpack that claim, that statement. If you're watching a car drive along the highway and you're standing on the side of the highway, as the car approaches you, you need to turn your head to keep looking at it. As the car passes you, you need to keep turning your head to keep looking at it. As the car is getting very, very close to you, the angle that you need to turn your head per second, let's say, the angle you need to turn your head per second to keep looking at the car increases and increases because its distance from you is decreasing. As the car passes you and then goes off into the distance, the angle you need to turn your head per second decreases because the distance to the object increases. In other words, the closer an object is moving at, let's say, a constant speed, the faster it will go through a particular angle of your vision. If the only reason Polaris was dropping to the horizon was because of distance, our distance from it, the perspective distance, then from the North Pole to 80 degrees north latitude, you would expect one amount of angle shift per mile or per degree. That would not be the same for the next 10 degrees of latitude down to 70. And it would not be the same for the next 10 degrees of latitude down to 60, and so on. Bev then makes a completely unsupported suggestion. Could perspective be 1 degree every 69 miles? Now, this would be exceptionally coincidental, exceptionally convenient that the law of perspective would happen to match perfectly with the with the distance between Polaris and the horizon. Problem is, 1 degree per 69 miles is a linear relationship, and perspective produces nonlinear relationships between distance and angles, like I just explained. An object moving at a constant speed past you will traverse a larger angle when it is close to you, and a smaller angle when it is further from you. That is why stationary things in the foreground seem to be moving faster than stationary things in the background when observing them from a moving object like a car or a train. Thus, if you're driving along the highway, looking at the guardrail close to you, and then trees beyond the guardrail, and then mountains far beyond the trees, the guardrail seems to be rushing past you very quickly, the trees seem to be rushing past you slightly less quickly, and the mountains in the distance don't seem to be rushing by at all, although their speed relative to you is the same. The further the object, the slower the angular shift. Then he goes into this talk about perspective is drawn as linear, and the geometric function of perspective is linear. I ask him to provide a definition. What is the geometric function of perspective? He doesn't provide this definition. Then I explain that the linear form y equals mx plus b can be used to describe the angle of Polaris above the horizon versus your latitude. The degrees between Polaris and the horizon is equal to 1 over 69 times your miles north of the equator plus 0, roughly. That expresses a linear relationship. And then he says, I'm confusing perspective geometry with an imagined curve. So he completely ignores the evidence I just provided. He completely ignores the mathematical linear equivalence between the angle of Polaris above the horizon and your latitude. Next, he obfuscates. He says, I'm confusing perspective geometry with an imagined curve. He asks, is my curve exponential? How do I get a linear function? I ask him what exponential curve he's referring to, and he doesn't answer. He asks instead, do I have a horizontal level, which is not an answer to my question. It's a non sequitur. I have to ask him again. And then he asks another question, do you not have a curved surface to look from? Certainly the surface of the Earth is curved. But this is not an exponential curve. But he doesn't do anything beyond obfuscate here. He doesn't answer my questions. And then he ends by repeating his unsubstantiated claim that when dealing with observations of Polaris above the horizon versus your latitude on Earth, you can't forget about the 1 degree drop per 69 miles as per perspective. I tell him he has yet to prove that perspective equals 1 degree drop per 69 miles. He responds with another non sequitur. And I decided to end my time on the server right then and there. It is a fruitless endeavor to try interacting with Bev. It's obvious if you're on his Discord, or excuse me, Emma's Discord, and it's obvious if you see his content on Twitter. And his YouTube appearances are an exercise in stupidity, to put it bluntly. So that was my encounter with Bev. If you've had an encounter with Bev and you'd like to share it in the comments below, please do.